Right, we're looking at the graphs of our distributions on pages 8, 9 and 10 of our workbook. So looking at our first example here, we can see that we're talking about a graph, okay, and it's a graph for 50 students. With that, we are looking at the axis of the equation, the graph there, and we've got the test score along one axis, and that's going up in steps of 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. On our next axis, we have our frequency, and that again is going up in steps 0, 1, 2, 3, 4, 5, 6, and so on. Now, if we look at each individual square represents that student, the score that the student receives. So when I'm looking at that number 8 that I've highlighted there, we're looking that there is one student who has a score of 8. Similarly, if I look at score of 10, there are 4 students that have that test score of 10. Okay, so let's move across now to question A. And this is saying how many students earned 12 marks. The key here is that they're asking how many students, so they're asking for a number, which is our frequency. So that's one of our keywords. They are also looking for how many get 12 marks. So exactly 12, not more than or less than, but exactly 12. So we can go across the bottom axis, our test score axis, and look for that mark of 12. Then once we have highlighted and identified how many people are in that, we can look across to what the frequency is, and we've got a frequency there of 6. So what does that tell us? Well, that tells us that there are 6 people who have got 12 marks in that test. Let's move on now to our next one, part B. So this is moved on to page 9. The question now is looking, what is the probability that a student got fewer than 10 marks? So the key part of this question is that we're looking for a probability now. Okay, so we're talking about either a decimal, a fraction, or a percentage. We're looking at how many students that got fewer than 10 marks. So we need to go down to our test score axis and look for all the values that are fewer than 10, so below 10. It's not including 10, it's up to 10. Okay, so it's everything that's below 10. So we're going to count the number of people that have scores below that. So we can see when I drew my little blue squares, there are 1, 2, 3, 4, 5, 6 people who got a score of less than 10. So now let's calculate the probability. So I can say the probability bracket that a student gets less than 10, close bracket, is equal to 6 out of the 50 students that are in our in this graph, and that's, if I put that into my calculator, I get 0.12, which is my probability, as we can see down the bottom. You can write either of these answers as either 6 out of 50 or 0.12. We will accept both of those. Moving on to question C now. What percentage of students got marks that were fewer than 10 or more than 16? So there's a number of keywords that come up here. Okay, so first of all, we're looking at what percentage of students. So when we get our answer, we have to give it as a percentage form. They also ask for getting fewer than 10 or more than 16. So there are 2 groups that we're interested in here. Firstly, we want to look at how many students got fewer than 10, so less than 10, not including 10, less than 10. We also want to look at more than 16. So we can't include 16 because it's more than, so we're looking from 17 upwards. So those are the two groups that we want to identify how many students are in those two groups. So now our next step is to count those number of students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 students who have got either a score of below 10, so fewer than 10, or above 16, so 17 or higher. So now let's write this down, and we can say that the probability that a student gets a mark of less than 10 or greater than 16 is 11 out of the 50 students, which is 0.22 as a decimal. But remember, we wanted to write this as a percentage. The question asked for a percentage, so we turn this into 22%. So in summary, for looking at what we're doing now, we can say that some of the key words that we need to look for when we're in a question is we're looking for whether we're looking for the number of, whether we're looking for a probability, whether we're looking for a percentage, a proportion, which is just another way of saying you could have any of those forms, a fraction, decimal, or percentage. We want to look for fewer than, less than, or more than, greater than, and those are all the key words we need to look for when we're doing a probability question like that. Moving on now to looking at the graphs of the distributions. What we want to do now is we want to be able to write an answer describing the shapes of it and describing the key features. So some of this will be familiar for you, okay? So one sentence we want to write look at the highest and the lowest values, your maximum and minimum. Okay, so in our sentence we want to describe where those 2 points are. We also want to look at the range, so what's the width from the smallest to the biggest, so maximum minus minimum. We want to look at our mode, and it could have more than one mode if the peaks are of exactly the same height. Generally it usually only has one mode though. And then we want to look at the shape. So we've got a number of these shapes that we're familiar with. Okay, we've got our normal distribution. We can have a triangular distribution, a rectangular, an irregular, or a bimodal distribution. So we've got some more specific names now. We then want to be able to describe whether the graphs are symmetrical or asymmetrical. So asymmetrical means not symmetric. If something is symmetric, it means that if I put a line down the middle of my normal graph, then the left-hand side is a mirror image of the right-hand side. If I do the same with the triangular, you can see that the left-hand side is a mirror image of the right, rectangular, and that funny graph that we have at the end there, a bimodal graph. With asymmetric graphs, though, we can't do that. So, for example, they're skewed to the right, because there's a longer tail on the right-hand side. If we put a line down the middle of that graph, the two sides would not be the same. They would not be a mirror image of each other. And equally for the skew to the left graphs. So let's just have a little example of how we write this up. So we've got to find these key ideas, remember? So the first thing we want to do is identify the smallest and the biggest, the minimum and maximum. So we've got our minimum at 4, our maximum at 18, and we're going to write that into our sentence. Then we need to find the range. So the range is maximum minus minimum. We can see that gives a distance there of 18, take away 4, which gives us a range of 14. We want to also identify the mode. So your mode is your biggest point. And in this case, we can see your mode occurs at 15. And then we need to describe the shape of it. And so we can look and see it looks almost triangular when I draw a little shape over the top. And it's asymmetric because it's skewed to the left.